and this is bones and skeletal tissues. The skeleton is going to be, and bones specifically, are going to be protected by an outer and an inner, and on either end, layer of cartilage. And the great thing about cartilage is that it doesn't have blood vessels and nerves, so things can rub against it and you're not going to perceive it, you're not going to feel it. The dense irregular connective tissue that is on the outside is called the perichondrium, and it does resist outward expansion. And there are three types of skeletal cartilage: hyaline, elastic, and fibrocartilage. So just as kind of an overview, hyaline cartilage supports, it's flexible, it's the most abundant skeletal cartilage in the body. They're presented in three forms. Articular hyaline cartilage covers the ends of long bones. Costal hyaline cartilage connects the ribs to the sternum or breastplate. Respiratory hyaline cartilage makes up the larynx and reinforces the air passages. And then nasal hyaline cartilage supports the nose. So you're going to find elastic cartilage in the external ear and epiglottis. It's similar to hyaline but doesn't have elastic fibers, so it's not quite as bendable. Fibrocartilage is used in the body where you really need a lot of strength, and it contains collagen, which is a very good structural fiber. And the meniscus of the knee is part of the knee that is going to have to bend as it moves. And also between the disc of your spinal cord or your vertebral column. So it is, and that provides kind of a cushion, and it allows you to do yoga poses. So it's going to be found in the intervertebral disc. So this is a lovely diagram that's color-coded. So this color is the bones of the axial skeleton, like the skull, and the vertebral column, and the ribs, and the lower part of the vertebral column, and the meniscus of the knee. The bones of the appendicular skeleton are obviously going to be your hands and legs. Hyaline cartilage is in blue, so you can see here attaching the ribs to the sternum and certain of the joints. And then elastic cartilage, there's a little bit here, and then also fibrocartilage, which is in red, and that, I'm sorry, that's going to be like in between. Do you see the red? That's in between the vertebra. So those are examples of where you can find these types of cartilage. Okay, so what is the function of the bone? Some of it you already know, and some of it just might need some brushing off of cobwebs. Support, obviously. Protection, obviously. Your skull does protect your brain. Movement, your joints. Now, mineral storage is something that's not obvious, but we'll find out that bones are made up of, or part of which bones are made up of calcium phosphate crystals. So you can deposit calcium into bone. You can withdraw calcium from bone. So the serum calcium levels, very often, if there's excess calcium, they can deposit it into bone. If they need calcium in order to maintain proper calcium serum levels, they can take it out of bone. So that's the mineral storage. And blood cell formation, red bone marrow. You have to go back once bones, once blood cells have aged and the spleen has picked them off. you have to go back to the stem cells, the hemopoietic cells, the pluripotent cells, the stem cells of the red bone marrow to direct the synthesis of new red blood cells, white blood cells, and platelets. Okay, so you have two flavors of bone: compact bone, and obviously that's going to be used for strength, and spongy bone. And spongy bone is there very much so is where you're going to deposit that red bone marrow so necessary for the formation of blood cells. All right, here we go. I am actually going to go to the I'm going to go to the diagram rather than read you those PowerPoints. So here's a long bone. This could be a femur. And what you have is you have the bottom and top, the top and bottom of the bone, which is called the epiphysis. And then the middle part of the bone is called the diaphysis. Spongy bone is found in the epiphysis. Compact bone is found in the diaphysis. You have a medullary cavity in the middle of the diaphysis that's usually filled with red bone marrow in young children and yellow bone marrow, which is fat, in older people, adults. The red bone marrow can be stored in the top and bottom epiphysis. Every part of the skeleton is made of living cells, and therefore the living cells need a source of blood. And I'm pointing right here to all of these canals, and the canals are found both in compact and spongy, but of course spongy bone is spongy, so it has many more little nooks and crannies in which to thread these capillaries. Capillaries are needed to deliver oxygen and glucose to the bone cells and to take away the waste products. So this is like a cross-section of a compact bone. And so you see the yellow bone marrow. You see the compact bone right here. It's arranged in long tubes that are cylindrical. And that gives a lot of tensile strength because a lot of the long bones are holding up a fair amount of weight. And I'm not going to hold you responsible for the perforating sharpie fibers, but in that you do have the arteries that branch into ever smaller arterioles and capillaries that are needed to deliver all of the nutrients to the bone cells that are located in the spongy and compact bone. The outer protective layer is called the periosteum, and the inner protective layer is called the endosteum. And so that gets into the endosteum, periosteum. I don't need you to know all of this, but just that it's a protective layer on the outside, a protective layer on the inside. All right, so short, irregular, or flat bones. I'm going to talk about the flat bones of the skull. They are very simple in their design. What they're really trying to do is to protect. So they do have a periosteum and they have an endosteum. The spongy bone in the bones of the skull are called diploe. And the outer areas are compact and the inner are spongy. They don't actually have a lot of structure, so they don't have a diaphysis, they don't have an epiphysis, but they certainly do have red bone marrow. And let me show you a picture. So here we go, skull bone. Now, what you want to have in a skull bone is you want protection. So you want the brain to be protected, and you also want the outside to be protected. So both the inside and outside of the skull is compact bone, and that is what's going to give you strength. The inner middle part is spongy, and that allows you to put red bone marrow in. And so that gives you an additional place in the body that you can go to when you have to make more blood cells. All right. I don't need you to know this, but obviously infants have way more red bone marrow than adults, and they tend to be located in a lot of the long bones as well as the flat bones in adults. Uh, as you can tell, it's going to get less and less. So it's just like the head of the femur and the humerus and the diploe of flat bones, but I'm not going to ask you questions about that. All right, so I am going to go to a picture and talk about the microscopic structure of compact bone. That's where most of your bone cells are. The compact bone is what is going to bear weight. And very often, that's the place where you break a bone. When you fracture a bone, the big thing to note in the microscopic view are these columns. They're very long columns, and they're filled with live cells. So I want to look at the live cells right here. They're called osteocytes, and these osteocytes are living cells. They have a problem, and the problem is that they are making bone and eventually are surrounded by bone, and they can't move. So you do have to have capillaries go to them in order for them to get the oxygen and the glucose and get rid of their waste products. And you want to have them alive just in case you break a bone, because then they can help repair. So, and the other thing too is as you grow and even as an adult, you want to be able to access these cells because they can help turn over calcium. They can be instrumental in depositing calcium and extracting calcium from bones and a lot of other functions. So as much as you don't think of your bones as being alive, they are very much so. The other thing I want you to note with this compact bone are all these canals through which capillaries are threaded. So they can be within millimeters of all these bone cells. And they were discovered by two individuals who get them named after them. So your Haversian canals, which are vertical, and then your horizontal Volkmann canals, and between the Volkmann and Haversian canals, you can get capillaries to all of the cells in this column-like lamella. And this is also just showing you spongy bone and then the interface between the compact and the spongy. But those are the only things that I would have in the quiz. All right. These are the different cell and matrix. Osteoblasts form bone. So at the edges of your long bone, you actually have these osteoblasts. They are able to make bone, but you really want to have bone cells that haven't yet got trapped in their matrix. Again, just in case you fracture. Osteocytes are going to be mature bone cells that are trapped, that cannot move because they're surrounded by bone. And then osteoclasts are going to resorb or break down the bone matrix. That's going to be the way that you make all these canals. And that's also going to be the way that you can extract calcium, where osteoblasts are going to be the way that you can deposit calcium. And then bone itself. Bone itself has to have some characteristics that make them bendable and other characteristics that make them mineralized or hardened. And you can't have them be too much of one or the other. It's almost a 50-50 split. You want them bendable, but not so bendable that you can't bear weight. You also want them not so crystalline that they are brittle. So the osteoid is the term that's used for the unmineralized bone matrix. They're made up of these fibers that are actually quite elastic. Proteoglycans, glycoproteins, and most importantly, collagen. So the flexibility of bone is due to the osteoid portion. And then you get to the crystalline or mineralized part of bone. It has the name from hell, called hydroxyapatite, and that is mainly calcium phosphate, and it gives the bone hardness and resistance to compression. And then the other half are your osteoids. So this is going to give you that bendability of the collagen, and the hydroxyapatite is going to give you the hardness of the bone. You need both. And so you have this alliance, or you have two components of the long bone, of any bone, and that's going to be the hydroxyapatite and the osteoid. And that is something that I do need you to know. There we go. Now, bone development is called osteogenesis, or the birth of bone. Ossification is the hardening of that bone, because when you're talking about a fetus, it doesn't harden all of a skeleton right away. So, and that has to do with the fact that the infant and toddler, young child, they expand their skeleton very quickly. And you want to have the bone development be laid down first and then ossified over time. Your skeleton is very ossified. A infant skeleton is a little bit more plastic, so it can expand quickly. And this is what we're going to be talking about, the formation of the bony skeleton in embryos of the fetus. Bone growth until early adulthood, and then in the adult, you don't get any taller, but your bone can thicken, you can remodel it, and you can repair it. So there are two processes that go on in the fetus. And the first has to do with flat bones, like your skull, and the second has to do with long bones, like your femur. So flat bones are called intramembranous ossification, and long bones are called endochondral ossification. And we will talk about them next. And for some reason, it starts in this PowerPoint and then continues in the next PowerPoint. And intramembranous ossification is the easier of the two to explain. And when we get to the next PowerPoint, I'll explain it in more detail. But these are the flat bones of the skull, the clavicle, and you have what are called mesenchymal cells, which form connective tissue. And I'll talk more about what mesenchymal cells are in the next PowerPoint. And that should be it. Yes. So I will see you for the next PowerPoint. Take care.